Okay, so today we're going over Module 13, still trigonometry, and the objective is students will find the three trigonometric ratios for a right triangle. So let's start off with this one. So pretty much still a review from the day before. So we're going to find sine, cosine, and tangent of A and sine, cosine, and tangent of B. So what we do first here is look at A. So circle A, and let's name the sides here. So this is the opposite, adjacent, and the hypotenuse. So we know sine is opposite over hypotenuse, so it's going to be A over C. Cosine is adjacent over hypotenuse, or B over C. And then tangent is opposite over adjacent, so it's A over B. All right, so now we move on to the other one, the other three. And this time the reference angle changes, so now it's B. So now I go from B here. So then it means that this side right here is now my opposite. This is my adjacent. And the hypotenuse remains the same. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay. All right, so now let's look at example 2. So again, you want to find sine, cosine, and tangent for angle F first. So let's start with F. So here I circle F. I go across. So this is my opposite side. This is my adjacent side. And this is the hypotenuse. So again, sine, opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay, now I go to the next angle, angle D. So here, let me just change the color. So I'm looking for angle D right now. So angle D right here, which means that if I go across, this means this is my opposite side now. This is my adjacent. And again, remember the hypotenuse stays the same. So sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. And then tangent is opposite over adjacent. Okay, now something to notice here is this one and this one. They're congruent. And also look at cosine and of F and sine of D. So these two are also congruent. Okay, so example 3. So here it says sine of x is 3/5, tangent of x is 3 over 4. Solve for cosine of x. So on my triangle, we'll just put in a 90-degree here. And I just label one of the angles x. So since that's x right there, let's call this one x right there. Okay, so now we know that sine is opposite over hypotenuse. Tangent is opposite over adjacent. And we know cosine is adjacent over hypotenuse. So if I look here, since this is my opposite side, this is the adjacent, and this is the hypotenuse. I'm just going to take the values they give me. So I know opposite is 3, so I'll put a 3 right here. Hypotenuse is 5, I'll put a 5 right here. And then the adjacent side is 4, I'm going to put a 4 right here. So I'm looking for cosine of x, I'm going to say cosine of x is, we said adjacent, which is 4, hypotenuse, which is 5. Okay, example 4. So right here, we're looking for, again, sine of A. So it means on your triangle, in a right angle. So we're gonna just let's call this angle A here. So we know sine of A is opposite over hypotenuse. You know cosine is adjacent over hypotenuse. And we know tangent is opposite over adjacent. So again here for A, opposite, adjacent, and this is the hypotenuse. So I know the opposite side is 1. I'll put a 1 right here. Hypotenuse is square root of 5. And the adjacent side is 2. So when I'm looking for tangent here, its opposite side is 1. Adjacent side is 2. So 1 over 2. Okay, example 5. Okay, so here again, cosine is adjacent over hypotenuse. Sine is opposite over adjacent. Sorry, opposite over hypotenuse. And cosine is again adjacent over hypotenuse. But if you look at the angles here, this is y, this is y. But on the cosine, you want z. Okay, so start off with, since we have y right here, we're going to start off with y. And now I'm going to name the sides. So this is the opposite, adjacent, and then the hypotenuse. So I know my adjacent side is 3. Hypotenuse is square root of 34. And then the opposite side is 5. Okay, but since I'm looking for cosine of z, so I know z, I want z right here. So that means I'm going to use this angle now. And now that means that this side over here is my opposite. This side is the adjacent. And then the hypotenuse remains the same. So here when it says cosine of z is the adjacent side, which is 5, over the hypotenuse, which is square root of 34. Which means that's my answer right there. Okay, now next example, example 6. Okay, so we're doing the same thing here. Okay, so I know tangent of M. So this is opposite over adjacent. I know sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. So looking at my triangle here, I'm starting with M here. So M, so this is the opposite. Let's put the 90-degree angle in there. This is the adjacent. That means this is the hypotenuse. So opposite is 7. Adjacent is 3. Which means the hypotenuse here is square root of 58. Okay, so but on the other end over here, we're trying to solve for cosine of n. So n's right here. So I know this side is my opposite. This side is the adjacent. And the hypotenuse remains the same. So I want cosine of n. So I know I want adjacent. Oh, sorry, the adjacent side, this one. So I want 7. So yes, I want 7 over hypotenuse, which is square root of 58. And that's my answer right there. All right, so now example 7. So it says solve for the missing side of the triangle. Okay, so let's look at what's given to us here. Here's square root of 44. Sorry, 44 angle 44. And let's look at the sides that are given to us. Okay, so I know this is the opposite, but there's nothing there. This is the hypotenuse. And that means this is the adjacent side. So the only sides I'm using here is this side and this side. So I'm only going to be using hypotenuse and adjacent. Okay, so I know that cosine equals adjacent over hypotenuse. So here I know you have the angle of cosine of 44 degrees equals adjacent side, which is x, hypotenuse, which is 13. So I calculate cosine of 44. So this gives me 0.7 equals x over 13. And I put this over 1. And then I just cross multiply right here. So I'm going to multiply these together. X times 1 gives me x equals, and I multiply 0.7 times 13. And that gives me 9.1. Okay, now example 8. So again, I want to solve the missing side. So here what they give us is angle 24. So this side is the opposite, which makes this side here the hypotenuse. And also the only two we're working with, opposite and hypotenuse. So here I know that sine of the angle is opposite over hypotenuse. So now what information they give us here, I have 24, so I'm going to take sine of 24 equals opposite side, which is x, hypotenuse, which is 18. So I calculate sine of 24. That gives me 0.4 equals, now here I have x over 18. So I change this to over 1. Cross multiply. So I take x times 1. That gives me x. And then 0.4 times 18. That gives me 7.2. So we're done with today's notes.